What's up, everyone? Welcome back to another math video. Today we're going to do an introduction to decimals. That's right, we're going to do an intro to what decimals are, where they're from. We're going to start renaming them, and then by renaming them, we'll understand how to order them, how to know whether one's larger or smaller. Let's get right into this. This is a place value chart, something that we've been familiar with for a little bit now, and we've learned how to write numbers using a place value chart. So for example, if we had, let's start in the tens, if we had 2 tens and 3 ones, we would have the number 23. At the same time, if we decided to have a number in the thousands, let's say 2 thousands, 4 hundreds, 3 tens, and 1 ones, our number would be 2,431. As you notice, the farther left we go onto this scale, the larger the number is. For example, if we had the number 8 in the ones and then we added one more 1, we'd have 9. And if we added another 1, we'd have 10 ones. But 10 ones is also 1 tens, and we'd have 0 ones left. So every time we add 1 to the previous place value, every time there's 10, it regroups to the next place value. What that could also mean is each place value is 10 times larger than the previous place value. Another example is to have 8 ones once again, and if I add 1 more, that's 9, and if we have 10, they would regroup over to the tens, and it would just be 1 tens. And at the same time, if we had 10 tens, and we regroup this over to the hundreds, we would have 100. So showing that the next place value is 10 times larger than the previous place value. So what does that mean for us in decimals? Let's zoom into the ones, shall we? If we had 1, 1, every number that we've talked about is a whole number. Now, what does this have to do with decimals? Well, decimals are something that are not whole numbers. They are less than 1. For example, we cut it in half. We now have 2 halves, which is commonly expressed as 1/2. So decimals are not whole numbers. Let's do another example. I've split the circle into 10 pieces. In fractions, we have a numerator and a denominator. The denominator means how many pieces does it need to make a whole? And here I would need 10 pieces. So to make a whole, I would need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. If I was to take out one piece, just like this, I would have 1 piece out of 10. And that's what the numerator is for. So this 1 piece out of 10 would also be known as 1/10. 1/10 can also be written as 1/10, which can also be written as our decimal form of 0.1, which is also known as 1/10 and 1/10. These are all the same. So you see how the fractions are related to decimals, 1/10. Now, let's get into the place value chart to see a larger picture of what these decimals mean. Here's the place value chart for decimals, and I want you to note that the ones is separated by something called a decimal point right here. For example, when we had the number 8, the technical term would be 8 decimal, and there were 0 tenths. So it can also be commonly written as 8.0 to represent the number 8. Similarly, any whole numbers can also be written as something 0.0, like if we had 222, it can also be known as 222.0. So the 0 represents the decimal, and it shows that we've got 0 decimals, which also means that it is a whole number. If we understood that whole numbers get larger as we go left, then decimals get smaller as we go right. So let's understand this. If we continue to add to the ones, the numbers on this side would get significantly larger. Well, the numbers as we progress towards the right will get significantly smaller. And let's show you some examples of this. Let's familiarize ourselves with the place values. We've got tenths, hundredths, thousands. And there's this pattern. If you remember, to the left of the ones, tens, then the hundreds, and then the thousands. And the similar pattern here is tenths. Mind the THS to show that is a decimal, hundredths, thousandths, and then just like on the left side, it goes 10,000ths, 100,000ths, and then millions. Just like moving to the left, it becomes 10 times larger. Moving to the right, each place value becomes 10 times smaller. I'm now going to show you a chart to show you that it gets smaller and smaller. All right, here is our 1, right? It is 1 whole, and now we're going to divide it into tenths. What does that mean? It becomes 10 times smaller, or we just cut this up into tenths or fractions. You can now see that there's 10 portions. So it is now divided into tenths if I had one of these. Now, if I wanted to take these tenths and make them 10 times smaller, well, they would turn into hundredths. So if we shaded this one cell, that is 1/100th that has been shaded. Well, what if we divide it into thousandths? That's right. If we take this one cell and we divided it 10 more times, because again, the farther we go to the right, it gets smaller by a factor of 10. So let's take this one area and turn that into this area. That was the 100th. Now, if I really wanted to get 1,000th, I would shade one of these cells. That is 1,000th. And remember, this whole cell, when it was divided into hundredths, was 100th. And then this 1 whole tenth here demonstrated 1/10. As you can see, it gets smaller and smaller and smaller every time we continue to go down to the right of that place value chart. Okay, so let's see some numbers. Okay, now here's an example of regrouping, and we're going to make it 10 times smaller. So if we take this 1/10 and we move it over to the hundredths, it now moves from 1/10 to 10 hundredths. If we had 1/10 and now we have 10 hundredths, which one is larger? We might tend to think that because it says the word hundredths, it is so much larger than the word tenths. And because we have a larger number in 10 and a smaller number in 1, we tend to think that the 10 hundredths is much larger. But remember, these are decimals. They're smaller than a whole number. So how can we understand what numbers are larger and smaller when using decimals? If we take a look at the place value chart, we know that any of the numbers that are heading towards the left will always be a larger number. So what that means is 1/10 will always be larger than 4 thousandths. 2 hundredths will always be larger than 5 thousandths. And again, why? Is because the hundredths place value is always larger than the thousandths. And similarly, tenths will be larger than thousandths. The farther we go to the left, the larger the number is. Last example, 1/10 will always be larger than 8 thousandths. 1/10 right here is significantly larger than the 8 thousandths that you see right here. Let's rename some of these decimals so it becomes easier for us to understand. All right, for my class, I've created this thing called a decimal placemat. We don't need to worry about all these bells and whistles and colors. Let's just figure out how to rename decimals. This is the only thing that we want to be concerned with. Now let's use some examples to understand how to rename these decimals. If we had the number 3 and we had 0/10ths, we could rename this decimal as 30/10ths, because if we had 3 ones and 0/10ths, we would still be able to name this 30/10ths. If we had 0/100ths, which is the exact same thing, it would now be called 300 hundredths. Let's write that up here. 300 hundredths. And how many thousandths would we get? Well, you guessed it. We would have 3,000 thousandths. Let's take another example. So this decimal, 0.24 or 0.24, can also be renamed as 24 hundredths. The chart below will show 2/10ths and 4 hundredths. So as we rename on this place value chart, I want you to be very mindful. If we have decimals in the tenths place, but also in the hundredths place, we go from the rightmost place value, and that's what we would call it, to say 24 hundredths. Because if we regrouped these two, and it looks like glasses, and we put them here. If we moved this, we would get 10 here, and if we moved this, we would get 10 more. So in fact, we've got in these two 20 hundredths, and we would add these four. We would then have 24 hundredths. All right, quiz time. Can you rename this decimal for me? 5.29 in the thousandths, please. Feel free to pause. All right. Were you able to get 5,290 thousandths? Well, you're right. Let's do one more. Can you please press pause now and figure out what this would be in the hundred thousandths, please? Were you able to guess 10,900 hundred thousandths? Well, that's it. You just successfully renamed decimals. All right, let's land this airplane. Today's flight, we were able to understand what an introduction to decimals are, and they are fractions of a whole number. And we did the example that 1/10 is all the exact same when we take a look at how you write them out. We also noted that 1/10 is larger than 10 thousandths because the farther right we go onto the place value chart, the smaller the number becomes. So we were able to compare which decimals are larger and which decimals are smaller. And the last thing we were able to accomplish was to rename decimals. 1/10 is equal to 10 hundredths or even 100 thousandths. Hopefully you're able to understand decimals a little bit more. If you had any difficulties or troubles, I highly suggest that you would go back, rewind, take some notes, and review this video. If you have any questions, please ask them in class. By understanding how decimals work, it's going to be a lot easier as we add, subtract, multiply, and divide these decimals. So again, if you didn't understand how the concept of decimals work, please, 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 I beg you, rewatch this video. All right, I'm signing out for now. Happy mathing, everyone.